Hello everyone, welcome to the channel. In this video, we will see how D'Alembert principle is used to solve a problem of pulley. The problem states that at a given instant, the 50 kilonewton block A is moving downward with a speed of 1.8 meter per second. Determine its speed after 2 seconds. Block B has a weight of 20 kilonewton and the coefficient of kinetic friction between it and the horizontal plane is 0.2. Neglect the mass of pulleys and the string or its cord. So we have to use D'Alembert's principle to solve this problem. Okay. So first of all, I'll write down the given data. So given data are so mass A they have given as they are given as weight. So I'll write down the weight first. Weight of A is 50 Newton. So mass A will be equal to 50 divided by 9.81. Okay, so if you put it in the calculator, you'll get as 50 divided by 9.81. It's 5.01 Newton. Okay, again, so weight of block B they are given as 20 Newton. Okay, so the mass of block B will be equal to 20 divided by 9.81. This will be equal to 2.4 Newton. Okay, so these are the given data, and we have the frictional as well. They have given the coefficient of kinetic friction. So here, if you see the diagram here, the block B is resting on the horizontal plane. So here we'll have the frictional, that is mu B. Okay, so mu B will be equal to, the value for frictional is 0.2, and the velocity of A block, okay, the velocity of A block is 1.8 meter per second, and it's going in the downward direction, right? Okay, so right, so these are the given data. We have to use a D'Alembert's principle to find the velocity, okay, to find the velocity of A when t equal to 2 seconds. Okay, so you have to find the velocity of A when t equal to 2 seconds. So if you see here also they have given the velocity of A in downward direction. That means we can take this as a initial velocity. Okay, so this can be taken as initial velocity. Okay, initial velocity. Fine. Okay, so now we'll look at the diagram. Then we will create the, again this is a pulley problem, so we will create a kinematic relation. So for frame the kinematic relation, we have to introduce the tension. If you see this this entire string is a single string, right? It is going here and it's going to the connected to the block B. Okay, so here we'll have tension in the ropes. That means we'll have the tension in the rope in this manner. So from the fixed end, we'll have a tension in this like this manner, and again we'll have a hover like this, and it is going downward as well. This is a fixed pulley, so this is a movable pulley. That means it will move in up or down direction. So this block is having the tension, it is hanging downward, so here also we'll have a tension T. Okay, now we have a single tension. This is from the fixed end. Okay, so here also coming we have a fixed end. So from this side, from the right hand side, we have a tension over here. From the left hand side, we have a block B. So from the block B, we'll have a tension like this, and this tension is transferring over here as well. T. If you see, and we have both the tension Okay, we have two tension acting over here at the block A. Okay, so this is upward, this is downward. So here we'll have 2T. Okay, so in block A we have two types of tension. In block A we have single tension, and the fixed also we have single tension. Okay, now if you see, if you want to make the work done as well, kinetic relation, so this can be as a reference point. So from here to here, okay, so here to here we have a distance of XA, and here also we have a distance of XA as well, right? We have a two tension, right? So we also we have a XA. So from here the distance moved will be equal to XB. Okay, so XB. So we have one XB and we have two XA. So if you see, we have only two blocks A and B. The equation now, the equation for this problem kinematic relation will be solution kinematic relation. Again, the virtual work principle will be using, that will be equal to 0. So we have a single B, that is tension into XB minus 2 times of tension into XA. This will be equal to 0. Okay, this will be equal to 0. So here if you see, again we can take the T as common. So getting T as common, XB minus 2 times of XA will be equal to 0. So if you take the T to the that side, we have XB minus 2 XA will be equal to 0, right? So from this equation we are going to differentiate with respect to T. Differentiate with respect to T, will get velocity, that is Vb minus 2Va will be equal to 0. Again differentiating with respect to T to get the acceleration. Respect to T will get the acceleration, that is A suffix B minus 2 A suffix A. This will be equal to 0. So if you see, the acceleration of B is equal to 2 times of acceleration of A. Okay, this is our first equation. Now we have to frame equation in terms of A and B to get the tension and the acceleration. Okay, so we are going to consider the FBD. Consider FBD for block A. Block A. Okay, so if you see, the block A is in downward direction. Block A. So we had a tension of 2T in the upward direction. Okay, the direction of the block is downward. Direction of the block is downward. Okay, this is positive. Direction of the block is downward. So we'll have a weight is also acting downward. So weight they are given as 20 newtons. So we have converted into 9.81. That means, so not for block A, it is for block A, it is 15 Newton. So if I convert it into weight, it will be 5.01. No, sorry, it's in the Newton only. I'll take it in the Newton, 15 Newton. Okay, so this is the block A, and we have to use the D'Alembert's principle, that is f of y, summation f of y minus m a y will be equal to 0. This is the D'Alembert's principle in the vertical direction. Here f of y is nothing but all the vertical forces, right? So we have to consider all the vertical forces. We have a 2t which is opposite to the direction of the block, that will be minus 2t, and we have 50 Newton is acting downward, so plus 50 minus mass is nothing but, we have already calculated in the given data, mass of A is 5.01. Mass of A is 5.01 into acceleration of AY, right? So here we don't know the acceleration, so this will be a constant. So A suffix A, I'm writing it as A suffix A 0. So we will keep the equation in terms of A suffix A. Okay, so this will be equal to if you want the equation in a suffix a, or else okay, we can keep it in the form of t as well. So t will be equal to this 2t will can be go to over that side. So 50 minus 50.1 a suffix a divided by 2. Okay, this will be divided by 2. Okay, so this will be equal to t will be equal to 25 minus 2 point, if I divide by that 5.01 divided by 2, it's 2.505 505 a suffix a. This is your first equation from block A. Similarly, consider FBD for block B. Okay, in block B, if you see block B is resting on the horizontal surface, right? It is resting on the horizontal surface, so we'll have a friction as well. So since the block B, since a block A is moving in downward direction, block B will move in this direction from left to right, right? Okay, so block B will move in left to right direction. So the direction of the block B is like this direction. So we have a tension over here, it's a T. So its direction is from left to right. The frictional force will be right to left, mu B dot N. So we'll have a normal reaction as well. We'll have a weight will be acting downward. Weight. Okay. Now, so these are the active force acting on the block B. So again, by using D'Alembert principle, we can use first. We can find out the normal. So f of x will be equal to f of normal. To find out the normal, we have to use the fy minus m into ay equal to 0. If you see the block is not moving in y direction, so this ay will become 0. So f of y will be equal to 0. So w is acting downward, so negative. Normal is acting upward, so positive. This will be equal to 0. So n will be equal to w, that is the weight of the block, that is 20 Newton. Okay, so this is the value for normal. Now we have to find f of x minus m a x equal to 0. So here we are using block B, so the acceleration will be AB. So in f of x direction, we have a tension. In horizontal direction, we have a tension that is similar to the same direction of the block, that is positive, and we have a frictional force as well, negative to the direction, minus the frictional force is 0.2, normal is 20. Okay, so minus of mass is mass of the block of B is 2.04. We have considered that 2.04. Mass is 2.04, and acceleration of the block will be AB. So this will be equal to 0. Okay, so again we are going to keep this in the form of T as well. So T will be equal to this, all these are minus, so I'm going to take this to the other side. So 0.2 into 20 will be equal to 4 plus 2.04 AB. So this is your second equation. If you see the first and second equation, we have a common of T. So I'm going to equate these two equations. So from the first equation, equating equation 1 and 2. Okay, so we'll get 25 minus 2.505 AB, sorry, AA suffix A, block A. So this is equal to 4 plus 2.04 AB. Okay, so we know that AB equal to 2.505 a suffix a, this will be equal to plus. So we know that ab is equal to 2 times of a 2a, right? 2 times of a suffix a, that means 2.04 into 2 times of a suffix a. Okay, so if you solve this equation, we will get a suffix a will be equal to, just a second, let's solve it, solve the equation. The acceleration of block A is 3.189 meter per second square. So this is the acceleration of the block A. It's going in downward direction. Okay. So now we are supposed to find, what we're supposed to find. We have to find the velocity of the acceleration. So velocity of the block A when time equal to 2 seconds. Okay. So here we'll be using the equation of motion, that is v equal to u plus at, right? So here we know the initial velocity equal to 1.8 meter per second, and they have given the time equal to 2 seconds, right? And we know the acceleration is equal to 3.189. Okay, so we can find out the velocity. So velocity va will be equal to u is 1.8 plus 3.189 into 2. So okay, if you put it in the calculator, just a second, 1.8 into 1.8 plus 3.189 into 2, right? 2 seconds. So it gives me a value of 8.178. So VA is equal to 8.178 meter per second. So this is the final answer we are required from this problem. The velocity of the block A after 2 seconds, it will be 8.178 meter per second. I hope you understood this problem. If you have any doubt, you can put it in the comment section. Thank you for watching.